Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Aaron Syme, founder and CEO of WebRTC Ventures. WebRTC Ventures is a custom design and development agency focused on building live video applications. We're here to help you take your application live. You can learn more about us at WebRTC.Ventures. Thanks for joining us live today on YouTube, LinkedIn, and Twitch, and welcome also to any of you watching a replay of today's event. For those of you with us live, you can ask questions throughout the stream by leaving a comment in whichever platform you're viewing this on. For today's episode, I'd like to welcome two members of our team, Hamza Nasir, a WebRTC developer, and Hector Zelaya, Senior DevOps Engineer. Thanks for joining me today, guys. It's great to have you here.
Thank you for having us.
Thank you for having us.
Oh, great to see you both. I'm really interested in these topics. I think this is going to be a really great episode. So thanks to both of you for sharing your expertise here today. So we're going to do this as two separate presentations today from Hamza and Hector, and we'll take questions after each presentation. For those of you watching live, you can put in your questions anytime, and we'll make sure to get to them. Hamza, you're going to go first with a presentation on attention detection in video conferencing. And then after that, Hector will present on automating configuration for WebRTC. So two different but very interesting topics, so stick around for both of them today. And again, for those of you watching live, you can ask questions anytime and we'll get to them as soon as we can. So Hamza, if you're ready, we'll go ahead and share your screen.
Awesome. I'm ready, Aaron.
All right. All right, take it away.
Okay, awesome. Good morning, good afternoon, good evening, wherever you are. Today we're going to be exploring a neat feature that you can build with Vonage Video APIs. It's called attention detection. So let's first start with the why. So would we want to build attention detection? Why is this needed in today's world? So we have a post-COVID, the world has moved to a more remote point of view where basically conferences, education, every sector that you could possibly think of is moving to online video conferences. And for some, for example, in education, when the professor or the teacher is delivering a lecture, attention detection is key, so that they know that what parts of their lectures is making the audience snooze, or versus which parts are making them jump and actually retain attention. That's one use case. For another use case is keynote speakers, right? So I'm sure a lot of you have tuned into the presidential debates that happened a while ago and many other debates. So for those speakers, they could deliver their speeches and use attention detection to actually kind of gauge and monitor their speeches and see which parts they could improve versus which are already good or actually spark interest in the audience. There's also multiple studies done in the advertisement and marketing sector, which draw correlation to head pose estimation and water retention, or whether somebody's going to buy a product. So and head pose estimation is going to be the primary thing that we're going to use to basically calculate attention. And there's many more applications for this. These are just some that are fairly common in today's world. So before we jump into the more interesting demo and everything, let's just talk about how we're going to achieve this. So we're going to use TensorFlow's media pipe. It's basically a machine learning model to kind of make a mesh of your face. And and by that, it would basically take your face or a picture of a face of your face as an input and basically create these landmarks, these data points on your face, which we will use to calculate attention. Now, we don't need all of the points on your face because there's quite a lot of them. But what we're interested in is the roll, the yaw, and the pitch of your face. So to calculate the roll and the yaw, and in a second you'll see what like you'll be able to visualize what the roll and yaw is. But basically, to calculate this, we just need the 2 points in the corner of your eye. So your one corner on the right eye and the one corner on the left eye. Similarly, to calculate the pitch, we just need 2 points, one at the top of your face and one at the bottom of your face. So this picture, this GIF was generously given to me by one of my colleagues who actually worked on me with me on this. So as you can see, this library creates, these are the data points that it creates based on your face. And right now you can see that Rahul is going to, so now this is the pitch, sorry, this is the yaw, and now this is the pitch, so up and down. And then if he turns his face like rotate clockwise or anti-clockwise, then that's going to be the roll. So, okay, great. We have the roll, we have the yaw, we have the pitch, but then how do we actually translate this into an attention score metric? So we basically we were influenced by this paper by these PhD students that basically they did head pose estimation, but they used neural networks. We used a much simpler form for that, but we used their attention score algorithm, which is basically you calculate these angles between the yaw and the pitch, um, and the roll, and you translate that angle to a 0 to 2 based score. And then you multiply everything together to basically get a value from 0 to 4 based on attention, based on the angles. Uh, so you can make like you can kind of play around with these categories and this part, this algorithm part, where you can make it more strict or you can make it more loose when it comes to giving you an attention score metric. But we basically made 4 categories, which is we said, okay, 0 to 1, no concentration, 1.1 to 2, low concentration, 2 to 3, medium, and then 3 to 4, very high or high concentration. This isn't how, like, this is something that you can just kind of play around with and see what works for you. And I'm pretty sure that for my demo, I've actually changed some of these values. But that's how you can categorize uh, these attention values. Okay, so now for the fun part. How do we integrate this with Vonage Video APIs? Vonage, just to give like a quick intro on what Vonage Video APIs is. Vonage Video APIs is a CPaaS platform which allows you to build a video application, video conferencing application from scratch in just like a couple of lines of code, right? So a key part of that library is that uh, when there's a concept of publisher and subscriber, but this is something that I don't want to get into, and I'll assume that the audience is familiar with this. But basically, the publisher, so me, I will uh, I will use my stream to calculate an attention score for myself, and then using Vonage's signaling API, I will send that to everyone else in the call. So basically, I'll calculate my own value. Let's say it's 2.7, and then all of the other 5 people in the call, I'll be like, hey, my attention right now is 2.7. So the number of times you run this per second is effectively your frames per second that you're getting information for. So if you're publishing your stream at 60 frames per second, then yeah, you could essentially run this 60 times per second. But if your stream only supports 30 frames per second, then running this 60 times a second you're just losing computational bandwidth. So there's some drawback to this architecture. So another use case could have been that, hey, like I just run this model on every one stream in the call on my machine. That would take a lot of CPU and GPU, and that would potentially crash the application. So this way, you're using more networking bandwidth, but you're actually saving on CPU and GPU per usage per participant. So now for the fun part, for the demo. Um, so this application right here is built with basically these couple of sample applications that Vonage provides you, and I basically put them into one and built the attention detection stuff on top of it. So if you'd like to run this demo on your machine and just kind of play around with it, this is the link that you could follow, and just clone the repo and run it. But yeah, okay, so demo time. Over here, hello, hi everyone. So over here, you can see that it's just, it looks like a normal video conferencing application. But I don't know if you can see, but there's a label over here which tells you what kind of attention it is and the value. So like I said, this value goes from 0 to 4. And the border is also kind of indicative of what the attention is right now. Now, if I look dead center and if I'm like completely focused, you'll see that it's saying perfect attention. But if I start to kind of gaze away slowly but surely, you'll see that the attention value just drops to 0. And this can be in any direction. It can be up and it can be down. So that's how it records attention, and it's a numerical value. So uh, that kind of gives us more uh, like data to play around with. I love this project because first of all, me and my colleagues came up with it in sort of a hackathon. And what we built was that we had AWS transcription. So we were actually able to map the history of the call since it started, and with the exact words of the presenter, map an attention value to all of the participants. So I would be able to tell if what I'm saying right now is boring you or if it's actually interesting you. And I think that's incredible. That's it for the demo, and now I'm going to turn it back to Aaron.
Thank you so much, Hamza. That is really interesting. Definitely appreciate you sharing that knowledge with us, and we've got a lot of lots of applause for you in the comments of this. By the way, on YouTube, Twitch, LinkedIn, where you're watching this, feel free to drop a question in there. But we definitely appreciate all the good vibes from you as well. So, Hamza, I have a few questions for you about this. I do think this is a really interesting um, project, and it's definitely the type of thing that I think could have application in a lot of different use cases. I think it's also a good example of where I tend to think like all technology is neutral, but it can be used sort of for good or bad depending on your intent as a technologist and how you apply that technology, right? So, do you have any thoughts on how to balance the privacy concerns of users with the benefits that an educational institution, a school, or a business might get from something like this with attention detection?
That's a very good question, Aaron. And I think that's a very valid concern for, if you join a video call on Google Meet and suddenly it's detecting your attention, you're like, okay, we're like, what are they doing with this information?
Right.
But the way I envision this, and the way I built this for this demo is that we use TensorFlow's JavaScript library, which runs on your browser. So all of the information you calculate your attention on your machine, and then we communicate that using the signaling API, which is kind of like the WebRTC data channels.
Mhm.
It's I'm not sure if it's exactly that, but you could, in theory, use WebRTC data channels to basically send this information peer to peer and
Mhm.
not communicate it through any server that could potentially store it or
Sure.
do something else with it.
Yeah. Yeah. I mean, it's all in how you architect it, right? I mean, the paper that you referenced is a interesting algorithm that you were able to apply in the application, and then just how you use it, how you store that data is where the privacy benefits. I also private privacy benefits or risks can come into play depending on the use case in the application. Yeah, it makes me think too of like a lot of times when you call in, a traditional phone call into customer service, you get a message that's, this call may be recorded for customer service purposes. That type of just a heads up warning that, anything you say on this call might be recorded. So, I could think of the same that if you're using this in a educational, like a remote exam proctoring solution is a type of scenario where companies want to know, is the student cheating? Are they looking somewhere else than the exam that they're taking? That's the type of situation that an algorithm like this can be really interesting and helpful in flagging that maybe we need to go back and look at the recording of the student to see if it appears like they were cheating when they were doing this remote exam. That's the type of situation where this could really be useful, but it also is a good idea to let the user know that that's happening when you come into this application, right? Uh, Hamza, another thing is I think interesting too is your any algorithm is not going to be foolproof, of course, but it's really interesting how you're looking at the positioning of the head to determine attention. I'm one of those people. I might be in really deep thought, but I tend to look off into the sky like that as I'm thinking, and that might make it look like I don't have not paying attention. Another, I know, also in some cultures, your head pose, a head shake, or a head nod can convey different things and different implications about whether that person is in agreement with you, disagreement, paying attention, not paying attention, etc. Um, what do you think about that? Like, how would you go about sort of testing this or thinking about what those numbers mean in different use cases in different situations?
That's a very good question, Aaron. And the answer to that is that there's multiple ways you could approach that problem. You're absolutely right. Some head poses, for example, right now when I was agreeing with you, I was head bobbing. And in what I've implemented for the demo, that would just basically like kind of bubble my attention low and high based on my head bobs. But that's not exactly what that means.
Right.
So TensorFlow actually has a library which you can use to detect iris detection. So it's called iris detection. It detects the movements of your iris. So it you with that theoretically you could know if I'm looking at the screen right now,
Hmm.
even if I'm head bobbing, but my iris
Mm.
position is the same, then that means that I'm still paying attention. It's just that I'm, gesturing with my face.
Yeah.
That's not something that I've implemented right now, but that that could be a very, if combined with head pose estimation, I think that could give you a very accurate attention score metric, regardless of, head movement. Like
Yeah.
not completely based on head movement.
Yeah, absolutely. Yeah, what other things like that would you consider combining with this pose detection in order to improve like the efficacy of the results or the type of information that you're able to gather or infer?
Yeah, so another thing that you could do is you could basically, based on the lighting. So right now, based on my lighting, it could be hard for the TensorFlow library to actually measure my depth. So if I'm close, if I'm
Mm.
based on certain points, it might not be able to read the depth that accurately. So you could adjust the lighting or basically based on the lighting, interpret the landmarks differently to be able to get a more accurate reading for those roll yaw pitch angles.
Hmm.
Another thing that you could do is that it's not always just one person in one screen. So there could be another person with me. So you could expand this library to calculate these metrics for multiple faces as well. So those are both things that I think can be good improvements to get a better attention score metric.
Nice, I like it. Yeah, that's great. And then one last question, and then I'm gonna bring Hector back to the conversation here shortly as well. But I have one last question for you. Have you tried this application while wearing a face mask, Hamza? Does it still work? Does that affect the results?
That's actually a very good question. I haven't tried it, but I would assume that if the face is humanoid enough, so it has a nose, it has an eye, it has a mouth, then I think it would still work because that's still, it resembles a human face. But yeah, if you just have a complete black mask, yeah, I don't think it'll be able to pick
Right.
up pick up on that mask. Yeah,
Maybe
absolutely.
if the face mask has like the nose and the mouth printed
Right.
out.
Yeah,
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 exactly. Some of the
exactly.
ones that look like a face. Exactly.
Yeah, exactly. Then I think it would be fine.
Yeah, absolutely. Awesome. Well, Hamza, thank you so much for that presentation. It's really interesting, really cool project. And we'll be posting this to the WebRTC Ventures blog in the future. And we'll also make sure to include links there to it as well. One comment, an interesting use case comment to consider here. So Mazu on YouTube, who's watching, pointed out, and he says an important detail here is that I could be paying attention without looking at the camera because I have multiple monitors here, for example, as I do as well in my situation. So yeah, depending on the use case, depending on who's using your application, it's a great point, Mizzou. Other things that you need to think about, how are you going to use this algorithm? What are the conclusions you're going to draw from it? And being careful about drawing too definitive a conclusion because certainly somebody with different monitors might be looking in different situations. So yeah, great point, Mizzou. Thank you. And thanks to all of you who have given a bunch of hand claps to Hamza in the comments. I'll give you one here as well myself. Great presentation, Hamza. Thank you. All right, so next up, we're going to have a brief little ad here. If you've enjoyed Hamza's presentation, if you're interested in working with us at WebRTC Ventures, this next 30-second ad here will tell you a little bit about a training program we have and a way you can join our team. And when we come back, Hector's going to talk to us about automating configuration for WebRTC. So that's also going to be really interesting. Stick around for that. As a viewer of WebRTC Live, you already know how important WebRTC development is to the modern web. Now it's time for you to grow your career by learning to build live video applications and joining our team at WebRTC Ventures. Go to WebRTC.ventures and apply to join the next cohort of our WebRTC training program. You'll have free access to advanced courses, mentorship from our team, and those who are accepted into the second month will receive a paid development contract and join our team of WebRTC development experts. Go to WebRTC.ventures now and earn your place in our team of video development experts. All right. So yeah, do check us out at WebRTC.ventures if you're interested in working with us or joining our team. Or that training program. We'd definitely love to work with you. And maybe you'll be in one of these learn from our own experts WebRTC Lives in the future. And speaking of our own experts, we're going to go now to Hector Zelaya, who's going to talk with us about configuration automation for WebRTC. So Hector, take it away.
Thanks a lot, Aaron. So we're going to talk about how we can automate configuration for WebRTC. One of the first things that we have to keep in mind when talking about automating configuration for WebRTC is the fact that WebRTC itself, it's not a solution. It's not a final product. Instead, WebRTC is a technology. It's a building block that you will be using along with some other building blocks to have or to build your final product, your final solution that you want in order to solve the specific problem that you are trying to solve. In that regard, the process of taking the building blocks, taking WebRTC and any other building block that you want to use, that process, it's a complex process. So we have some level of complexity to go from the pile of blocks to the beautiful parrot or whatever solution that you want to build. And the challenge here is, or what you will want to achieve is to find a way or think of a way to overcome or reduce that complexity. Because as you know, resources are limited. So you need to find a way to overcome that complexity and focus on the most important things that you want to solve. So in this regard is where automation can be helpful for your solution, for your process. But you also need to understand that it's not just matter of just clicking the button, writes a bunch of scripts, and voila, you will have your product already built, and you can just sit back and relax as the image is showing. So you need to understand what automation can do for you. And one of the first things, probably the most important, as I was mentioned, that research is something limited, is the fact that you can reduce the amount of time and efforts. Those are probably two of the most important resources in any kind of project, the time and efforts that you spend on a specific task. And if in each project, there are some tasks that can be repetitive, that you can have them in multiple projects, and they could be very similar or even the same. So you can reduce the amount of time and efforts that you would spend on those certain repetitive tasks. So that's something that automation can help you to achieve. And it achieves this by providing a repeatable process. So the idea is that you can build something once, and then you should be able to implement it then multiple times using one unique effort for building it, and then just taking what you have built and implement it in other project or other parts of the process. Another cool thing that you can achieve using automation is you are able to manage your configuration through version control. It's very likely that for automating something, you will be writing scripts, and those scripts are basically code that you can add into version control. You can track all the changes that you made, and you can have you can have versions of your configuration that you can roll back if you require to, or you can come back and revisit. So you need to also think about what automation cannot do for you. You cannot automate building the whole solution or the actual solution. There's still work that needs to be performed manually. And the idea is that you can automate what is repetitive and something that you can implement without having to spend too much time on it once you have it built, and you can focus on the things that are strictly required to solve the specific problem. Now, that's about what automation can do for you. Let's talk about the tools that we will use to automate. There are a couple of tools that we usually implement in most of our projects. Those are Terraform and Ansible. Let's just give a really quick overview of these two. So Terraform is a tool that allows you to automate infrastructure. It supports multiple cloud vendors. Some of the most important ones: AWS, Google Cloud, Azure. You can. It also supports some other other such as you can also build or build your Kubernetes resources using Terraform. We mostly use it for cloud vendors, but there's a lot of vendors that are supported by this tool. One cool thing about Terraform is that it's open source. So in addition to the fact that there are no additional costs on using the open source core of the product, you can also contribute. So if you want a specific feature that it's probably not not supported, if you have the resource, you can actually contribute and make it available. And with Terraform, you write scripts, you write some you write the resources that you want to provision, and that is code that you write and that you can add into version control and achieve infrastructure as code. So that's part of what some of the things that we do with Terraform. And on the other hand, we have Ansible. Ansible is for configuration management. Uh, this means that you already have your infrastructure up and running, and now you want to install the dependencies, install any required updates, make sure that the specific folders that you need exist on the server, use templates for the configuration, and put those templates on the server with the actual values that will make your product to actually work. So that's Ansible. The main difference with using Ansible with doing manually is that you can again build all your list of settings and all your list of dependencies and apply it on multiple servers at once. So that's like the nice thing about this feature. Ansible specifically, I like it, and this is a personal preference, of course, because it's you don't require to have a complex setup of infrastructure. You don't need to install any agent on the servers. It runs on top of the SSH protocol, so you don't need anything additional to I mean, if you can SSH into the server, you can definitely use Ansible to apply your configuration. That's what I like about it. And basically, the approach that we want to follow, this is a very simplified image, of course. We will want to use Terraform in a first step to provision the infrastructure. I'm using an EC2 just as an example, but we can totally use something different. We can use, if we talk about the AWS space, we can use ECS clusters, AKS, Elastic Beanstalk, or whatever compute service you prefer. You can provision it using Terraform. And once we have that piece of infrastructure running, you get your Ansible playbooks, your scripts, and you implement, apply all those changes in the servers or the instance that you already have up and running. That's basically the approach. That's basically the principle that we want to apply. So let's talk about what will we need to configure. So an important piece on each WebRTC solution are media servers and something called the ICE framework. Those are mostly the pieces of your setup that you will most likely want to automate. Let's talk a little bit about each of these. So a media server. A media server is a piece of infrastructure that sits in the middle of the communication between your clients. Each client will be in charge of get the media streams from the device. That's the video, audio, and even the data, if we talk about the data channel. And each client, each peer will take those streams and will send it to the other peers. But while you can implement something called mesh, where you have all the communication going client to client, that could, when as you add more clients into that mesh, things could get complicated, because you will need more resources to transcode, to decode, and to handle that much connection. So it makes sense to put something in the middle that takes care of that. So that something in the middle, that piece of infrastructure, is a media server. It's basically where you would delegate the function of, from simply routing the media streams to all the other peers, to even add recordings, or even transcode, or somehow manipulating the streams to make it do what you want. That basically are the things that you can do with a media server. There are a couple of approaches for that. In the image, if you if you get close enough, you will see that this is a media server that it's using an approach called SFU. SFU means that all the clients will send the streams to the media server, and the media server will route all the streams to the client, and each client will handle multiple connections. There's another approach called MCU, where again all the clients will send their streams, but the media server will be in charge of mixing all those streams into a unique stream that is then being sent to the clients. Sorry. So that's for the media server. Oh, and one thing before, all these translated into configuration. A media server is basically an instance where you will install specific software that will provide the media server capability. There are multiple options to achieve that functionality. We will explore one of them in an example in a couple of minutes. So now let's talk about the ICE framework. The ICE framework is what enables the communication to happen on first place. So we have in the image in the left of the screen, there are two clients that want to communicate each other. You can see that both clients are behind a router, behind a private network. So we can say that both clients are behind a NAT. Without any further processing, it's unlikely that these clients will be able to reach each other. So they first need to know how they can find the other peer. So in order to do this, we have the signaling process, and as part of that process, we have the exchange of ICE candidates. So an ICE candidate is a set of an IP address and a port that you can use to reach the other peer. And in order to know what are all the ICE candidates that are available, each client can perform a stun request. A stun request is basically asking an external server, hey, what is my IP address and what is my port? How am I looking from outside of my network? Or how am I looking on the internet? So that's one part of the ICE framework is the stun protocol, the ability for a client to know what its public IP address and what's the port that it's being used to go out to the internet. And in the image at the right, it can happen that after that clients make the stun request and they exchange that information with each other, when they try to reach the other client, we can see that the client in the right is also behind a firewall. So this firewall means that there are some restrictions on that network, and it's likely it could happen that the first client is not able to reach the second one, even knowing what is the public IP address and what's the port, because probably that port doesn't allow any inbound traffic. So in that regard, there's another component of the ICE framework called turn, which will be in charge of relaying. It will receive the media stream and will then relay it to the other client using a setup that will be allowed in the firewall. So that those are the two components: the stun and turn. And this, again, making the same translation that we did for the media server. You will probably want to have an EC2 instance if you're using AWS, but or more generic, you will need a server where you will want to install a specific software that will provide that functionality. And same as what media server, that specific software needs to be installed. You will need dependencies, and you will want to add configuration files, and that is where you will want to use the combination of tools that we have just mentioned. So we will see a very small example of how to do this using CodeTurn, which is a software for the stun and turn functionality, and Janus, which is a software for media servers. Of course, there are some other options. These are just a couple of tools that we have used in the past. So let's take a look at this code. First of all, this is a public repository, so you can go to this URL, clone the code, and you can experiment firsthand. So that you can know that I'm not giving you any lies here. So you can clone the repo, and I've added the instructions in case you want to set up your own pair of Janus and CodeTurn servers. You will basically need to, of course, you will need to have the Terraform and Ansible tools already installed. You will basically need to initialize the Terraform state, set some configuration for the region on AWS, set some variables that are required in order to make this work. And then, well, you just need to apply, because the code is already there. So you probably won't need to spend too much time on writing this. Once you have your new server, you can take note of the IP addresses and configure your Ansible inventory, and then just run the playbooks for Janus and for CodeTurn respectively. So this in case you want to get this up and running on your own resources. Let's take a look at some of the most important parts of the code. Let's focus first on Terraform. In here we have, let me make this a little bigger. Hopefully that will help you to see without making too much effort. So we will go to the main, which is where all the resources are being declared. you can see that we're using AWS on a specific region. You will probably like to change this. We are using Ubuntu AMI for the operating systems in the servers. Because we want to keep this as simple as possible, we are not building any VPC. We're relying on that it's already created. You can use the default one. There is no problem with that. We are selecting one public subnet, and we are currently getting this from the variables. Now, the important pieces are two AWS instances. These are EC2 instance, one for Janus, one for Coturn. We're using the same Ubuntu AMI. Both are relatively small because this is just for example purposes. We are using the public IP address. It's important to already have an SSH keeper so that you can log into the servers. And we are also declaring a security group to make sure that the required ports are open. We will take a look into this in a couple of seconds. We also want that our servers have the same IP address across reboots. So we are allocating a pair of elastic IP address, and we are assigning those IP address to the EC2 instance, and we are creating the security groups. The most important things to note here are the ports 3478 for Coturn. This is where the stun requests are being made. So we are basically just enabling the stun functionality right now. And for Janus, we are opening the port 8088, which is where you will make requests to the HTTP REST API for the Janus API, so that you can create rooms and you can create all the required resources to establish communication. There are more ports that you can open. You can always reach the documentation from Coturn and Janus and adapt this to what you really need. So this is basically the configuration. We have the code for the configuration. If we have a project, we can simply take this code and we will be able to have those repetitive tasks of setting up a server, configuring, and we can focus on building the actual code, on building the actual solution that will connect to the servers, and we can make sure that we are focusing on our efforts on what it's needed to solve the specific problem. So now let's talk about the other piece. At this point, we will have the infrastructure up and running, but there won't be any functionality as of right now. To do that, we will need to install the software, configure it, and that's where Ansible comes into place. So in Ansible, we write playbooks. Playbooks is a set of instructions that you will want to apply on your server. The first thing is that after that we have the servers up and running, we will need to take note of the IP addresses, and we will go into the inventory and add the information here. We are also adding an environment name. This is for the variables that we want to use. We will look into this in just a couple of seconds. And if we go to each of the playbooks, we have one playbook for Coturn, and we have one for Janus. So if we go into the Coturn one, we will see that we want to use the Coturn set of hosts in the inventory. If we have more than if we have multiple Coturn instances, we will simply add the IP addresses under the Coturn group of hosts, and this same configuration will be applied to all to the multiple servers. We are setting up the user that we want to use to log in. We are setting up that we want to be able to become a super user. And we're using a Ansible role from the Ansible Galaxy repository. This is a role that is already made. But of course, you can write your own roles. That's no problem. And we are specifying the variable file that we want to use for this role. And we will find a very similar structure for Janus. But the difference is that we're using a different role, a different Ansible role, again, from the Ansible Galaxy repository. This is one for Janus instead. And both roles are easily configured using variables. So you can check the documentation for the specific roles, and you will be able to see all the variables that you can modify. So if we go into the bars, you will find the dev file. If you have multiple environments and you want them to have different configurations, you can build multiple variable files here. And one important thing, as this is just for example purposes, we are not implementing any secrets protection. For a real world project, you will definitely want to somehow encrypt or using Vault to store all your secret information. But in this case, it's hard coded. We're not actually using this, so it's more for demonstration purposes. You can see that we are configuring an authentication secret for Coterm. We are currently disabling TLS for the Coterm server. We are setting some other configurations for Janus. Something about where do we want to install it, what are the version of the plugins that we want to use, some secrets for authenticating with the Janus servers, also which are the ports that we want to be available in the HTTP REST API plugin, and the list of the files. So that's all that you can configure. And once you have your code in the way that you want, you can take the inventory of your servers and run the Ansible playbook, and you will have your Janus, your media server, and your stand and turn server up and running. And that's pretty much it. It's a really simple example. Of course, there's a lot of improvements that can be made. We talk about adding some extra measurements to make sure that you don't have any secret. You can also work on a way to have not only one EC2 instance, but have multiple, and that you can somehow scale to support more users, or implement a way that you can add a way to monitor the traffic and be able to launch new instances depending on the need or on the usage. It's the same principle. You will use Terraform to provision the cloud resources, and then you will use Ansible to implement the configuration, and that's it.
Thank you so much, Hector. Really appreciate it. Yeah, great presentation. I think that this is so powerful, what you've shown here of how to use Terraform and Ansible. And I think it's something certainly we want to take more advantage of in our work at WebRTC Ventures. I think we've, as a company doing services work for lots of different clients, we've coalesced over time on some favorite architectures for different types of projects. And then combining that experience with like our expertise in AWS, this is a great way to get our clients to market faster. So, I want to thank you so much for that. And also, our industry colleague Dan Jenkins makes another great point here. And by the way, anyone who has any questions you want to throw in the comments now on whatever tool you're watching this on, this is the time. Dan says you can spend 2,000% of the time you normally would setting up the automation, but now it works the same every time. Dan sounds pretty certain about the 2,000% number. Have you measured that personally, Hector? Is that, or are you plus or minus?
Well, yeah, that will depend on the complexity, but the idea is that once you have that built, you can take it and implement it and maybe save more than that 2,000% in other project or other solutions that you want to implement.
Yeah, absolutely. And I made the comment that doing this sort of configuration work and automating of it is a way that we can get our clients to market faster. Dan brings up a really important point here too. It's also about reliability, right? And repeatability, as you mentioned in your presentation too, the repeatability of it. So now when you have to scale your infrastructure, set up more infrastructure, or you need to set up a staging or testing environment similar to production, or anything along those lines, you can use this automated configuration to do that more quickly after investing that upfront effort to configure it, of course, to create it, of course. But you can do it to add those other instances more quickly, and to be really confident that they're using the same configuration as the ones you currently have. So those are really important points too. So the example that you gave here, and we'll link to this in the blog as well, is Coturn and Janus. But you could use this with any sort of open source media server, any sort of open source project, even for projects around commercial APIs as well, right?
Of course, everything that can be installed in a server and that needs to be configured can be done using Ansible. Yeah. Totally.
Absolutely. And one last question. When, say, for example, you're using Janus as your media server in here, and the Janus project has an update, new version, how do you handle, how do Terraform and Ansible figure into that when you need to do updates to your infrastructure?
Ooh, that's an excellent question. So there's one thing that I didn't mention. First of all, this would probably be managed through Ansible. I mean, there are multiple ways to get to the same approach. We could take advantage on the ability to provision new infrastructure on the cloud, and one approach could be, okay, I use Terraform to launch a new instance. I write a new playbook with a new set of variables that install a newer version of Janus, and we can try to achieve some sort of blue-green-ish approach, where we will have the new fleet of Janus servers, and then we just take down the others.
Right.
We can, of course, use Ansible to achieve in-place update. There's one. This is the feature that I didn't mention. One thing that we try to achieve using Ansible is the fact that playbooks need to strive to idempotent. Is that how you pronounce it? Idempotent? But the thing is that when you run something multiple times, you need to make sure that you get the same result.
Right.
So that's one thing that you should strive when writing Ansible playbooks, and that is something that will allow to make in-place updates where excuse me one second. Okay. Sorry about that. So it's one thing that you should strive to, because it will allow you to change only what needs to be changed, and something that is already configured, Ansible won't touch that part because of the idempotency. Sorry, I can't remember how is that word on English. But yeah, that's basically two approaches that you can use to implement updates. Of course, there are some other ways. You can also add other tools into the mix. There's another tool called Packer that you can use to build custom AMI, so that you can build images of the instance and build new instances on top of those images. And you can also use Ansible with Packer to build the images, and then you use Terraform to provision the infrastructure. There's multiple ways, but the important is knowing the right tools, knowing the right principle, and or try to having fun while you spend 2,000% of your time trying to automate.
That's right, exactly. Well, there's a lot that we could do with this, definitely. And so, yeah, Hector, thanks so much for the time, the 2,000% of time you've invested in building this, and also for this presentation today, and to all of you for watching today. And we will put, as always, we'll put this video up on WebRTC Ventures YouTube channel, also on our blog at WebRTC.ventures, and there will be more information there too. So thanks again so much for joining us today, Hamza and Hector, both of you. Really appreciate both your presentations and the time. All right. Our next episode will be on Wednesday, August 24th. And our guest will be Fred Posner, a VoIP consultant specializing in open source communication protocols such as Kamaleo, Asterisk, and FreeSwitch. If you want to find out more about our upcoming episodes, follow us on Twitter at WebRTC Ventures, on Twitch, LinkedIn, YouTube, and join our email list at WebRTC.ventures. Thanks again, everyone, for joining us today. Let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.